it's all of 50 thousandths. That's all the difference there is.
No, they did a great job of matching that up.
Yeah. Wanted to show that they're basically the same here, and then measuring it here being different. Yeah, there's only maybe 40 thousandths difference between these two, so they're very close. This one is 1 inch 904, so very close. We're going to just take the overall depth that we took,
Yep.
minus the bearing retainer on the TKX.
Which is 1.904.
Right, and then what we're going to do is then subtracting the two of them, that will give us our bearing face-to-face measurement. So when we go over to the bearing, we'll measure that out and adjust the collar accordingly. We have to make sure that the bearing is also collapsed to its fullest,
Right.
or I should say the least position. Okay?
Okay, let's do that.
What's that number we're looking for, Mike?
We are looking for 1.155.
1.115?
1.155.
Why does that number sound so small to me?
Because it's supposed to be over 2 inches. Get something.
Oh, you know why? It's because we have to factor in the ruler. It needs to be 2 point, or that 980, whatever it was. We got to factor that in.
Oh, I got to add it to it. I get 2.140.
Okay, that makes more sense to me. Because we're taking a different approach with the installation of this TKX, Mike already had pre-installed his hydraulic system. He had converted this car from mechanical linkage to hydraulic, and the hydraulic system went in with a 4-speed ahead of time. We're taking a different approach and making sure that we have the measurements right. So our original measurement of 3 inch 55 thousandths was from this bell housing surface to the fingers of the clutch, and the measurement, again, we have to factor in the thickness of the straight edge. We also deducted from the earlier measurement that we took from the face of the transmission to the base of the bearing retainer, and we came up with a 1 inch 155. Now, because this measurement was done with the ruler on edge, on the previous measurement, we had to factor in the thickness of it. So we're making sure that we're on the same edge or plane as we take the measurement. So in this particular case, we're looking at 2 inch 140 as a measurement, and we're going to, that measurement translates to bearing face fully collapsed with this collar on the other side here. And that's ultimately what we're trying to adjust so that we get the bearing to transmission surface overall measurement. So in taking that measurement, we're going to come up, and right now we're at 2 inch 105, and our measurement was 2 inch 140. All we have to do is spin the collar outward, take a measurement again, and wow, I'm right almost on the money here. Let me just bring it back, and we are on the money. All right, so what we're going to do here is take a measurement of the fingers to the straight edge here. We know that the straight edge is a fixed dimension, and being that we're going to reuse the same dimension, we won't have to factor that into our measurements. So we're zeroed out. We're measuring from the ruler to one of the fingers of the clutch, making sure that we make perfect contact, and all right, we have contact there, so we got a measurement, and then we're going to transfer that over and then measure our bearing retainer. Because it's installed, we normally would measure from the bearing face to the transmission, but we don't wish to take the bearing assembly out and have to re-bleed it. So we're going to simply just take the measurement of the bearing retainer of the two transmissions, compare them, and then if they are slightly different, we'll calculate that into the landing point of the bearing retainer. to our transmission here. Yeah, I mean, again, I would like to have just a little collar showing because I want to make sure that I'm on that piece. So I'm pretty good with that. Again, if I have a slightly too much, I'm okay with that. If I'm too short, I'm not good with that.
Right.
Okay, I mean, in other words, if it's too tight,
Yep.
if we were to keep extending it, we keep pushing it in.
Yeah.
But if we have it further back, there's a margin of error there. Okay? So at this point, we are ready to look at putting our anti-rotational pin. On Mike's Muncie here, he had pre-installed a pin. The Muncie threads are different than the TKX. So we're going to provide with the Tilton 6000 series bearing, hydraulic release bearing, is a pin that comes with it with a proper size for the TKX. So it's a 3/8 size. We're going to extract one of the bolts from the bearing retainer. What we recommend, and in order to get the bearing in the right orientation, is to use the driver's side left bolt lower on the bearing retainer. So we're going to remove that, screw the pin into place using some blue Loctite, and torque to the factory specifications. One of the things that we had to address when doing a TKX install is that the mounting location of the transmission compared to the center line of the output shaft is actually taller or less distance compared to the Muncie that we just took out. It's approximately 3/4 of an inch to a 1 inch difference. So at Modern DriveLine, we provide a block that makes up the difference so we can match the two of them up. And we're going to head and pre-install this item here ahead of time, making this a whole lot easier as we go and put it in the car. So we're going to take a moment to do that. So I've got some hardware that came with our kit. We line up the holes of the transmission so that it is the same GM. This block is also supplied for other applications for a Ford. And so we're going to put our mount coming through, utilizing the two inner holes of our transmission. We're going to apply these parts together, lining up the holes. So we just got that one started for the moment. I'll come back with some Loctite here. Mike, if you would hand me some of that blue Loctite you had a moment ago. And we'll just put a little dab of that, keeping it from coming off the transmission since we're not going to be using a lock washer. So we're just going to run that one in, get it started. And the mount has a little bit of a slot to it, so you can move it a little bit left-right. We'll address that as we get inside the car and do the actual installation. But for now, we're just going to get this started, get these bolts snugged up, and then we'll torque them up here in just a bit. We take out the top bolt just momentarily, put the Loctite on it. A red Loctite could be used, but it's a little more permanent than the blue, so that's why I recommend the blue over the red. And yes, there is such a good thing as a green Loctite, but that is definitely permanent and typically used for bearings and sleeves, make up the difference in some machining, so definitely do not recommend the green Loctite. So go ahead and get this tightened up just a little bit. We do have our hardware ready here for the actual cross member. And as you can see, there's not a lot of play there, but we're just looking to snug that up, center it up for us here. And we're just going to snug that to a comfortable level. Torque rating on something like this should be somewhere around 25 foot-pounds of torque. When we do use the cross member, I want to show that this mount actually has 3 locations. Some GM applications, there's only a single hole in the center or a stud. In this particular application here, we're going to simply use the 2 outer bolt holes in our cross member because that's what the Chevelle is equipped with. So we can get started with this here and get it slid in. It should go together quite quickly.
Thanks for watching part 2 of this 5-part series, covering the complete installation of an MDL modified shift position TKX into a 67 Chevelle. Be sure to catch the rest of this series available at youtube.com/Modern DriveLine Inc., where you'll find a playlist. Subscribe to our channel to be notified. If the next episode in this series is already available, a link will appear now. Thanks for making it modern.